Okay, so in the exponential definition of sinh x, show that sinh to the minus 1 of x. So if I write y equals sinh to the minus 1 of x, then that means sinh of y is equal to x. Then the exponential differential of sinh y is e to the y minus e to the minus y divided by 2. So cross multiply e to the x as e to the y minus e to the minus y. I rewrite the e to the minus y as 1 over e to the y and multiply through then by e to the y. E to the y times e to the y is e to the y plus y, which is e to the 2y. That's 1, and then that's a quadratic in e to the y, so that's e to the 2y minus 2x e to the y minus 1. Okay, so I'm going to use the quadratic formula on this. So a is 1, b is minus 2x, c is minus 1. So e to the y will be minus b, so that's 2x, plus minus square root of b squared minus 4ac all over 2a, which is towards a 1. So that's equal to 2x plus or minus the square root of, right, square minus 2x, that's 4x squared, minus 4 times 1 times minus 1 is plus 4, all over 2. Right, 4 is a common factor in this, so if I take the 4 out, so it's 2x plus or minus square root of 4x squared plus 1. And square root of 4 is 2, square root of x squared plus 1 is x squared plus 1, all over 2. So 2 is a common factor on the top line. And 2's cancelled off, giving me that e to the y is x plus the square root of x squared plus 1, or x minus square root of x squared plus 1. Now then, e to the y, graph of e to the y is always positive. The exponential function is always positive. So the second term, x minus root x squared plus 1, is less than 0, because the square root of x squared plus 1 is a little bit more than x. X take away a little bit more than x is negative. Therefore, e to the y has to equal x plus the square root of x squared plus 1, and then if e to the y is that, then y is ln on the opposite side. So y was sinh to the minus 1 of x, so there's the proof. Okay, part B. I want to solve this equation. Cos 2x is 2 sinh x plus 5. Now I want to leave it in the logarithmic form. Okay, there's sinh x here, so the formula I use for cos 2x then is the one that involves sin squared x. So cos 2x is 1 plus 2 sin squared x. So sub in there, so that's 1 plus 2 sin squared x is 2 sinh x plus 5. Notice that for trig it would be 1 minus 2 sin squared x, so because it's hyperbolic, so I've got a sine squared, product of two sines. Osborne's rule changes that minus sign to a plus sign. So let's bring everything onto the left hand side. That's 2 sin squared x minus 2 sinh x. 1 minus 5 is minus 4 equals 0. Divide by 2. That's sin squared x minus sinh x minus 2 equals 0. That will factorise. So sinh x and sinh x 1 and 2, so I want minus 2 plus 1. So sinh x is minus 1, or sinh x equals 2. So x is sinh to the minus 1 of minus 1, or sinh to the minus 1 of 2. So using the answer to the first part, now if they didn't give that to me in the first part, I could get that from the formula booklet. Okay, on page 3 in the formula booklet, you see that these formulas are given to you there. Alright, we've already derived this one in part A, so I got the formula in any case. So sinh to the minus 1 and minus 1 then is log of minus 1 plus the square root of minus 1 squared plus 1, or putting 2 in, that's log of 2 plus root 2 squared plus 1. So that's ln of minus 1 plus, that's square root of minus 1 is 1 and 1 is 2, so that's root 2, or ln of 2 plus 2 squared plus 1 is 5, so that's root 5.